we solve another numerical example, how we find the A inverse with the help of a Gauss-Jordan methods. As we know that in a Gauss-Jordan method, we convert the matrix A into a diagonal matrix. Now suppose here, in order to save the time, here already we write the problem. What is the problem? Problem is using Gauss-Jordan elimination method, find the inverse of a following matrix. This matrix is a given. So how we find the solution? Here let what? Again let A inverse equal x11, x12, x13, x21, x22, x23, x31, x32, x33 be the inverse of matrix A. Now since we know that the property of A and A inverse, A into A inverse equal what? Equal I. A into A inverse equal I. So here we write what? Here we write A 3 minus 1 1 minus 15 6 minus 5 5 minus 2 2, and here we write A inverse. This one is x11, x12, x13, x21, x22, x23, x31, x32, x33. This one equal what? This one equal identity matrix. This one is a 1 0 0 0 1 0 0 0 1. As we know that this one converted into a 3 system of a linear equation. Suppose this one is a what? This one is a, here we denote this one is a x1, column vector x1, and here we denote this one is a column vector x2, and this one denoted by the column vector x3, and this one is a first row means of a identity matrix. Suppose this one is a I1, this one is a I2, this one is a I3. Then this equation number 1, this one converted into a 3 set of a system of a linear equation. What is the 3 set of a system of a linear equation? First one is a Ax1 equal I1, second one is a Ax2 equal I2, and third one is a Ax3 equal I3, where x1 is a what? X1 is a column vector x11, x21, x31, and x2 is a x12, x22, x32, and x3 be the x13, x23, and x33. Similarly, I1 is a first column of our identity matrix, I2 be the second column of our identity matrix, and I3 be the third column of our identity matrix. So Ax1 equal I1, Ax2 equal I2, Ax3 equal I3. Now we write a augmented matrix, not augmented matrix, augmented system. Now augmented system. Now augmented system is a what? Matrix A, partition. Here you may also say this one is I1, I2, I3, or you may directly write the I. Now what is the values of A? Here we write the values of A. Values of A is a what? Values of A is a 3 minus 1 1, 3 minus 1 1, and second row is a minus 15 6 minus 5, minus 15 6 minus 5, and third row is a 5 minus 2 2, 5 minus 2 2, 5 minus 2 2. Partition, here we write a unit matrix 1 0 0 0 1 0 0 0 1 0 0 1. So now we convert this matrix A into a diagonal matrix in a Gauss-Jordan method with the help of a row transformation. And meaning of this one, we first normalize the first equation, then perform the row operation and eliminate the first variable from second, third variables. So for this one, first we choose the pivot elements. What is a pivot element here? Pivot element is a pivot element equal here 3, and this one does not equal to 0. So we may apply the Gauss-Jordan method. If pivot element equal to 0, then we cannot apply the Gauss-Jordan elimination method. Then by performing the partial or complete pivoting, we try to convert pivot element does not equal to 0. So pivot element equal to 3 and this one does not equal to 0. Now we normalize the first equation. So for the normalization, we perform the here pivot row is a what? Pivot row is a first row. Pivot row is a R1. So we perform the normalization on R1. R1 equal what? R1 tends to 1 by pivot element. Pivot element is a 3 R1 for the normalization. For normalization. For normalization, okay, for normalization you may write here for normalization. So after normalization, what is the equivalent augmented system? If we multiplied by 1 by 3 in R1, then this become 1 minus 1 by 3, this one is a 1 by 3 partition, this one is a 1 by 3 0 0. And there is a no change in a second and third row. So this one is a minus 15, 6, minus 5, 0, 1, 0 and 5, minus 2, 2, 0, 0, 1. So after the normalization, we eliminate the first variable from the remaining equation. Means except the first equation, we eliminate the variable 1 from the second and third equation. For this one, we perform the row operation R2 in a non-pivot row. R2 tends to R2 minus what? R2 minus pivot element means here non-pivot elements. This one is a minus 15 divided by pivot element. Here pivot element is already we normalize, so there is a no need to divide with the pivot element. So this one is a minus 15 R1, you may equivalently say that R2 plus 15 R1. This one eliminate the first variable from the second equation. Similarly, from the third equation, we perform the R3 minus 5R1, 5R1. Means a non-pivot row minus pivot row, non-pivot row minus pivot row, and there is a multiplication or division in a pivot row only. This one is a rule. So what is the equivalent matrix? Equivalent matrix we come here. Here, what is the equivalent matrix? So there is a no change in the first row. 1 minus 1 by 3, 1 by 3. So here partition, here 1 by 3, 0, 0. In a second row, R2 plus 15 R1. So this becomes 0. R2 plus 15 R1, this become minus 15 by 3 plus 6. 6 plus 15 by 3 means 18 by 3. So 18 by 3, this one is a 15 by 3, 18, this means 1. So if we multiplied by here 15, this become 15, 5, 6 minus 5, this will become 1. And this become 15 by 3 minus 5 plus 15 by 3. So this become 5 and this become minus 5, this one becomes 0. Okay. Now what will happen here? R2 minus 15 R1, this become 5, 15 R1 because 15 by 3, this become 5. there is a no change 1 and there is a no change 0. So 510. Now for the third one, so what will happen here? R2 minus R3 minus 5 power 1. So this becomes 0. Minus 2 minus 5 by 3. So minus 2 plus 5 by 3. So this one is a minus 2 plus 5 by 3. So this one is a minus 1 by 3, because minus 2 plus 5 by 3, this becomes 6, minus 5, 1 by 3. And second one is a 2 minus 5 by 3, means this one is a 2 minus 5 by 3. So 2 minus 5 by 3 means 6 by 3. So this one is a 1 by 3. And this one is a R3 minus 5 by 3. So this one is a 5 by 3 minus 5 by 3. And this one is a 0 and this one is a 1. So here we eliminate what? Here we eliminate the first variable from the second and third equation. Now again, what is the pivot element here? Pivot row is a R2 and pivot element is a element equal what? 1. This one is a pivot element. So there is no need of a normalization, because pivot element is a 1. In a normalization, what we will do? In a normalization, we try to convert the pivot element into a 1. So here pivot element is already 1 and this one also does not equal to 0. So we able to apply the Gauss-Jordan elimination method, and there is no need of a normalization because pivot element is already 1. So here we perform the what? Here we perform the elimination of a second variable from first and third equation. For this one, we perform the row operation. R1 tends to R1 minus plus, here minus 1 by 3. So here minus 1 by 3 R2, and this one is equivalent to, you may say, R1 plus 1 by 3 R2. R1 plus 1 by 3 R2. Similarly, in a R3 again we perform what? R3 tends to what? R3 tends to, once we verify either this one is a correct or not, minus 1 by 3, obviously this one is a correct one. So R3 tends to what? R3 plus 1 by 3 R2. 1 by 3 R2. So what will happen here? 1 by 3 R2. So now what will happen? What is the equivalent matrix? This become what? This become, there is a no change in the first column, so 1 first column, and first row this becomes 0 because R1 plus 1 by 3. So R1 plus 1 by 3 here. So 1 by 3 minus 1 by 3 and 1 by 3 0. 1 by 3 and here 1 by 3. So this become 1 by 3. So now here 5 by 3 plus 1 by 3. So this become 6 by 3. So what is the value of this one? 6 by 3 means 2. So this one is a 0 and 1 by 3. So this one is a 1 by 3. So this one is a 0. So this one is a 0. And second row there is a no change because this one is a pivot row. 0 1 0, 5 1 and 0. And in a third row what will happen? This one is a 0 and R3 plus 1 by 3 R2. So this becomes 0 and this become R3 plus this become 1 by 3. There is a no change, and here we multiplied by the 5 by 3. So 5 by 3 this becomes 0 and this become 1 by 3, 1 by 3 and this become 1. So this one is a what? This one is a elimination of a second variable from first and third. Now what is the pivot row here? Now pivot row become third row. Pivot row become R3. Now what is the pivot element here? Pivot element pivot element is a 1 by 3. Here pivot element is a 1 by 3. Now, if pivot element is a 1 by 3, then we perform the normalization. R3 tends to 1 upon pivot element 1 by 3 R3, or equivalently you may say R3 tends to 3 R3. So here we perform what? We multiplied by the 3 in order to what? In order to perform the normalization. Here we write a normalization. So after normalization, what will happen? Let us write in the next page. So after normalization, what is the value? This value become what? 101 by 3. 101 by 3. 101 by 3. Second row become what? Second row become 010, 010, 010. Third row become 001 by 3. 001 by 3. 001 by 3. Now partition. Now we write a 2 1 by 3 0. 2 1 by 3 0. 2 1 by 3 0. And here 5 1 0. 5 1 0. And after normalization, here if we perform the normalization, then 1 by 3 become what? 1 by 3 become 3. 1 by 3 multiplied by 3, then this become 1. And this one become also 1, and this become 1 by 3. So what we write here, rather than to write a 1 by 3, we write what? 1. So this one is a, because here we multiplied by the 3, then this become 0, this become 1, this become 1 by 3. 0, 0, 1, 1 by 3. 0, 1, 1 by 3. Now we perform what? We perform the elimination. Elimination of a third variable from first and second equation. For this one, we perform the R1 tends to R1 minus 1 by 3 R3. 1 by 3 R3. There is something wrong that when we perform the normalization, we multiplied by the 3, then this become 1, and this become 1, and but this become what? This become 3. If we multiplied by the 3 here, 3 R3. So this value become what? This value become 3. So that's why there is something wrong. So this one is a 3. So 0. So when we perform this operation, R1 minus 1 by 3 R3. So this become 1 0 0, 1 by 3, this becomes 2, this becomes 0, and this become R1 0 minus 1 by 3 R3. So this become 3, and 3, this become minus 1. Now there is no change in a second one. So 0 1 0, 5 1 0, and third row becomes 0 0 1, 0 1, and 0 1. This become what? 0 1 3. So 0 1 3. So if partition B, then what is the value? What is the A inverse? So for A inverse in a Gauss-Jordan method, directly we write the values of a x1 1, x1 2 like this one. So now if we write a reduced form of a system of a linear equation, now reduced form of a system of a linear equation, reduced form of system of a linear equation, system of a linear equation, system of linear equation. This become what? First one is a 1 0 0, 0 1 0, 0 0 1, and here we write a x1 1, x2 1, x3 1. This one equal what? This one equal 2 5 0. second system of equation is a what? 1 0 0 0 1 0 0 0 1. Here we write a second one, x1 2 x2 2 x3 2, and this one equal to what? This one equal to the second column, 0 1 1. Now third one is a what? This one is a second system of equation. Now third one we write here 1 0 0 0 1 0 0 0 1, and what is the third one? x3 1 x3 2 x1 3 x1 3 x2 3 x3 3. This one equal to the third column. So minus 1 0 3. So as we know that in a Gauss-Jordan method, directly we write the values of unknowns. So what is the value of x11? So A inverse equal x11 x12 x13 x21 x22 x23 x31 x32 x33. So this one equal to the, if we observe the first set of a system of a linear equation in a reduced form, means in a diagonal form of a matrix A, then directly we write x11 equal what? 2, x21 equal 5, x31 equal 0. So this one equal 2 5 0, and second one is a 0 1 1, and third one is a minus 1 0 3. So this one is a A. Now what will happen in a Gauss-Jordan method? You may also write directly from here. This one is a what? A inverse. This one is a A inverse. So this one is only a procedure, means we write a set of a system of a linear equation, then directly we write the value of x11 equal to 2, x21 equal to 5, x31 equal to 0, x12 equal to 0, x22 equal to 1, x32 equal to 1, and putting the values in a A inverse. Now what is the summary of this lecture? If any non-singular matrix is given, then be able to find out the inverse of that matrix with the help of a Gauss elimination method or Gauss-Jordan methods. So to find out a inverse, first of all we assume that A inverse is a square matrix, in a square matrix of the order of a square matrix of A, and we assume that this one is x11, x12, x13 like this one, and we assume that these are the unknowns. Then by using the property of inverse of a matrix A into A inverse equal to I, then we write a set of a system of a linear equation. Then we write a augmented system rather than augmented matrix. Then we convert in a augmented system. In a Gauss elimination method, we convert the matrix A of augmented system into upper diagonal matrix, upper triangular matrix, not upper diagonal matrix, upper triangular matrix. And in a Gauss-Jordan method, we convert in a augmented system the matrix A into a diagonal matrix. Once we converted into a upper triangular matrix in a Gauss elimination method, we perform the back substitution to find out the values of A inverse, and in a Gauss-Jordan method directly we write the value of unknown of A inverse. So this one is a way how we find the values of inverse of any matrix, any non-singular matrix by Gauss elimination and Gauss-Jordan method. Thank you. Thank you for watching my lectures. Thank you.